So we starting now. Thank you for coming for this tutorial on sharing computation environments with Pixi. So the agenda will have three parts, each one of approximately 15 minutes with 5 minutes break. So we try to go as slow and smoothly as possible for everyone to follow up. So on the first part, I'll go with slides, just so we have the same information. And then the second and third part will cover some examples. So what's a computational environment? For context, computational environment includes everything that you use to do your computational calculation, from your storage to your CPU and your operation system and your Python, R, any other library that you're using. In terms of sharing your computational environment, for this presentation, we will be mostly talking about your libraries, so your Python, R, or any other library. We're going to exclude a little bit of your operation system and CPU and storage. So why do we want to share our computational environment, or a little bit of things that we wanted to do? We want to get operation system and language agnostic, so we can use the same tool for different operation system and programming language. We want the user that's going to reuse our environment to not need any administration permission. We also want to avoid the dependency help for our users, so complicated chains that are not resolved. I also want to facilitate for users to report bugs when they have things, and if possible, we want to also share some shortcuts, alias, for them to be able to use our environment. So Pixi is a tool that had been released more or less 2 years ago that cover most of the things that we wanted to do in terms of sharing our computational environment. We're going to give time to install it later. I just want to give a few more other informations. So how does Pixi organize things? So given that you have your home directory and your projects, so in this case here, there's empty cars and iris as your projects. Pixi will create a hidden folder called .pixi that it stores some libraries that you install. So that's how Pixi do. It follows some conventions on other package managers to keep your libraries, your dependencies for your project on your project. This is a little bit different of how Conda does things, because the Conda has its own folder. So here on .conda/environments, and it stores there, even if the name of your environment is the same, Conda will store files on a separate different that's not on your project. That's one difference to keep in mind between Pixi and Conda. So there's another thing that people generally ask is why use containers or when use containers. So containers is great if you have to run two databases, for example, two servers to run simultaneously, and it's something that Pixi will not help you very much doing that. Or if you have different C standard libraries that get conflicted, containers can help you that. But the most important thing here is if you're trying to get a fully isolated thing from your libraries and what you already have on your machine, containers will get you this full isolation. Pixi will not. So if you have some programs installed system-wise, Pixi can still access that, which a container will not be able to. A few more things about Pixi. How does Pixi works and how it's able to operate? Pixi uses its own package repository. It keeps its own copy of dependencies. It do a full lock on the dependency tree when you have your dependencies. And every time that you run Pixi, it checks all the dependencies. So this avoids dependencies to have been changed when the user was working on other projects. if there's any question at any moment, feel free to interrupt me. To do that, Pixi has some requirements. So Pixi primarily use packets from CondaForge. So if you use it to get packets from other places, you will have to try to bring your package through CondaForge if you're trying to get a seamless experience. Pixi needs a little bit more computational because it do this check of the computational dependency tree every time. It's also, we end up duplicating some libraries for each one of your projects, which requires a little bit more storage. And because it will download any new dependency, it also requires some internet connection from time to time. Generally, this would be a problem, but it's not anymore. Or generally, we expect that people are using computers that has a lot of CPU, RAM, and a fast internet connection. But you should keep in mind when using Pixi that those requirements might be a limitation for some users. So what files Pix use internally? So there's a pix.tone, and that's a human readable configuration. Pixi as a tool has some commands that will help you manage this file, so you don't need to always edit it by hand, but it's a human readable configuration file. This is a very small example that has some metadata at the top, and there's a list of dependency here on line 10 as a Python dependency. Pixi will also create a pixi.log file. So this is a machine readable format file that is where Pixi store all the dependency version controlling for internal use. This is a not example. I did trim some parts. Here's line 8 and 11 to make it fit on the screen, but you can see it defines the channels here at line 5 of you're using, and it define the packets like on line 14. We're not going to get into detail, just for information purpose. And as I mentioned before at the beginning, Pixi will store all files on a hidden directory called .pixi. You should not manage that. If you're following some Pixi commands, it will add .pixi to .gitignore and other places. So you're not going to have to manage that or see that file often. This is also like an example of how it would look like. It did some trim to fit on the screen, but you can see that you install some libraries like Python and create some alias and some other dependencies. So I already talked quite a lot. So what I want at the moment before we did the break is to install Pixi. If you never had done before, you can install on Windows or any Unix-like system. If you need more information, you can find here on the installation section. So I'll paste the link on the chat, and I will pass the commands here also. And for Linux users. So I will soon flip from my presentation to two browsers, so we can have demo session. So on the left here, there's a PowerShell, Windows PowerShell, and on the right, it's Ubuntu running on WSL. So I will perform both installations of Pixi on both environments. So I will pass this on the PowerShell and we'll run the installation, and I also will run that on my Ubuntu machine. And at this point, if you're installing, we're going to have a small break. So it gives you time to install, which should take a few minutes. Is the installation going run for everyone? Can I get some thumbs up or confirmation? Looks like people are being able to install at the moment. So it complete on both places. One thing that it is important here is that you should close and open your terminal again so it can load the new path for Pixi on your systems. I did previously install Pixi on both environments, so I'm not restart my shell, but you should close and reopen on the shell. So at this moment, I just want to give a small break for 5 minutes, and we recollect at 11:20. If you have any questions, you can put on the chat, or you can speak yourself. I'll just go back to the slides to if you need to see the installation. Is everyone back? I hope so on that. So we can give continuity to our tutorial. So now we're going to start our first example. So for this example, we use Sarah's use case. So Sarah wants to load some course material that she's studying. She wants to learn programming using Jupyter Notebook or Jupyter Lab. She do data analysis with R, and she do some data visualization with ggplot. So the first thing that we going to be doing is to get the computation environment that her instructor did share with her. So you first paste here on the text. You can use Git to clone. So I will do this on my Linux shell, but you can also do on your Windows shell if you have Git installed. I don't have Git installed on my Windows shell, but I did previously downloaded the files. So after you downloaded the files, you should change to the directory. So you can do a cd dir minus ttt minus course minus pixi minus mwe. And if you type list, os, you should see that both directories, both here on my machine on Windows and Ubuntu, both have the same files. Did everyone already had time to git clone the repository? If you need more time, you can just type on the chat or raise your voice. So we have Pixi installed on both environments. The instructor from Sarah, she adds some alias. So we can list the alias using Pixi task list. So it works on both Windows and Ubuntu. Pixi task list. Don't know what happened here. It might be that I got old version, or I'll try to debug this later. you should get a list of the tests that have on the Pixi environment. There is two tests. There is create figures and lab. Create figures will create all figures in the PDF format, and lab will start the Jupyter lab ID. I will try that later, Martin. So for the moment, we can do Pixi run lab. So this will start and execute the alias that was created by the instructor. So you notice that once you run things, Pixi will resolve the dependency tree for you. So this should take a little bit of time for you to have all the dependencies installed. So we should give some time for everyone to install the dependencies. And after you install the dependencies, or Pixi install the dependencies for you and start the Jupyter lab server, you should have an address to use to start the Jupyter lab. Did everyone manage to get the dependency installed? Can you give me a thumbs up when it finished? Just giving time for it, Pixi to install the dependencies for you. Okay, good. So if you have, sorry, you should, I can't help you at the moment with permissions denied from GitHub. You should be able to download a zip folder. The repository is open. If you have all the dependencies installed, you should be able to click on the link or copy the link that Jupyter provided for you. So I'll open here. So I paste the link, and you should have access to Jupyter Lab or Jupyter ID. From there, here on the site, we'll try to increase the font. On the left panel, you have notes.py. So you can open this notebook file. It's running here the R kernel, and you can press to execute the cells with the play button on the top. So it runs the cells for you. How is at the moment for everyone? Did you manage to have the Jupyter Lab open and running the cells? So as I mentioned, this Jupyter Lab is running on the Pixi environment with R. You can test any R command if you want. Things should work as you use it to have things working on R. So this is the first example. Any question here at the moment? So I'll go back to the shells. So if when you are on GitLab running the server, if you want to stop, you can press Ctrl C. Ctrl C to stop the Jupyter server. It will ask you for confirmation. So we will confirm with Y, and that will interrupt the Jupyter server. The other thing that we saw is that it had another task. So you can run Pixi. If you run Pixi task list, you remember there is two tasks. We saw the lab, and now there's create figures. So I first list the files here. There's a fig1.r folder that you can inspect later, but we want more interesting on the Pixi task here. So we can run Pixi run, then the name of our task, create figures, and you can press return. So this will load all the dependencies. Pixi will do that, and will execute this R script fig1.r -- vanilla. That's programmed on our Pixi configuration file. So now if I list the files, you see there's a new fig1.pdf. If you want to open that file, you should be able to open with any of your PDF readers. If you're interested to know the Pixi configuration file, we can show here on the screen, pixi.tom, and you see there's a session here that describes what commands is going to be used when you call run. So tasks.lab, we'll call jupyterlab -- no browser, and create figures, we'll call iScript fig1 -- vanilla. So you can create any alias, any task that you want. We'll see that on the third part. For this part, there's one other thing that I wanted to show. So we saw Pixi run create -figures before. So run takes an argument that is passed to the Pixi runtime. If Pixi doesn't know the alias, Pixi will run the program that you pass on the Pixi environment. So we can run a NB convert, for example. So I'll pass the command here. So you can do Pixi run Jupyter. As I say, there is no alias called Jupyter that we define on our pixi.tom file. So this means that Pixi will just call Jupyter from the environment that Pixi has. And I can call NB convert. I can convert nuts.pynb, and I can convert that to a script. So I can press return. Pixi will check the internal dependencies and will run the NB convert. So now, if you type ls, we're going to see there's a file called notes.r, and I can show this file for you. then a cat nodes.r. So that has all the R code that we previously saw on our nodes.ipython. How we are here so far? Questions? No, I didn't say that, Jan. I will have to follow on that later. Probably there's some late changes on Pixi that might have required that one. Any curiosity at this moment that people might want to have? As I say, you can use the Pixi run with any command that you have. You can run Pixi, run just Jupyter Lab if you want, and that will start Jupyter Lab for you instead of using our lab alias. If you want to start R prompt with do your own script, you can. That's also possible. And if you want to pass extra arguments, you can also do so. If I can do Jupyter run Pixi run lab, and I can pass a port if I want, which I don't remember if -minus port is the command. It is. So in this case, anything that Pixi will check if they have an alias, a test called lab, which it has here. So it's Jupyter Lab, no browser. Anything after new arguments are going to be appended to the alias here. So it becomes quite flexible. And for debugging purpose, Pixi will show here what's running. So it's calling a task lab. Task lab is running this one by default, and you pass this extension. Any questions that you have? Moment. So we're going to make a short break for 5 minutes, and then we're going to look at the next example. No, we don't need to run Pixi run lab. You can run directly Pixi run Jupyter Lab if you want. That will also work. You can do both. So you can do Pixi run Jupyter Lab. That also work. There is no need. The lab is just an alias for this example. So we'll show the next example at 11:40. You can take a break. If you have more questions, you can ask me on the chat, or you can unmute yourself. Okay, so it's 11:40. We're going to restart. So thank you, Yam, for explaining what was happening with the Windows thing. So I make the change here. So I add all the platforms to this workspace. So on workspace platforms, so there's now Windows, Linux, and Mac OS. So now when I do PC desk list, it will show the tasks here. And if I do Pixi task lab, sorry, Pixi run lab, it will resolve the dependencies and start the Jupyter lab. So let's go for our example back to where we were. So, oops. What is that point? Sorry. So there's a cheat sheet on the slides if you're following this later. So we're going to talk about Renata's use case. So Renata is a course developer. She do data analysis with R, and she do data visualization with ggplot. So on this story, we kind of did a inversion of the natural order of things. If you doing development, your use case is like Renata, so you share your computation environment. So that's what we're going to do on this use case. So we have here both on Windows and Ubuntu, as we mentioned before. So one important thing here is that we should go for a different directory. So I can do live demo, cd live demo. So there's a live demo on both my Windows and my Ubuntu machine. So it's a new directory. It's empty for both. So the first thing that you should do when you working with Pixi, we'll do a Pixi init. That's it works on both. It will create the pixi.tom file for you. We can inspect what is on the pixi.tom file. I don't know if works. So here you will notice the first difference that is quite new change. I will have to look later when this was fully introduced and change. But when you do your Pixi init, it will look on what operation system you're running, and they will add to these platforms. So on my Ubuntu machine, it will add Linux 64, and my Windows machine, it will do add Windows 64. So as we learned on the beginning of this lesson, if you want to have cross operation system, we will have to change this line to include all the other lines. So I'll write here on the notes to make your environment mode OS. So I will do just here on the Ubuntu one. I will open Vim and change that one just for sake of example. So as I say, if you want to have all the platforms, you have to change here. So Pixi init will create the Pixi tom file for you. After you create your environment, the second important thing is that you want to add your dependencies. So you can do Pixi add Jupyter lab, for example. It works on both. Pixi add Jupyter lab. So Pixi will look of all the dependencies tree, all the packages on Conda Forge, and we'll find the latest version of JupyterLab that's compatible with your platform, and we'll install that. After things had it concluded, it will show what version had been installed. We can look off how Pixi Tom looks now. So you see that there's a entry on the dependency. It works on both files. So we install JupyterLab. If you remember our use case, Renata used R, so we should also add R. So you can use this Pixi add with more than one dependency. So you can do Pixi add R base. So that's the core of R. You can add ggplot to, and we want to use this Zeus kernel for R. So Pixi add R minus base, R minus ggplot2, and Zeus minus R. It works on both base, ggplot2, and Zeus R. So I'll pass on the chat the full command if you were looking for. So Pixi will add the dependencies. We can check how the Pixi .tom file did change. So now we have the dependencies here. It's similar for both. So that's the dependencies. If you start an environment on this, now you have all those 4 dependencies. So now our use case here, Renata, she wants to add alias, a task for the students. So we'll go Pixi task add, so different than list before. So add, and you first give the name of the test that you want. So let's say lab, and you can say Jupyter lab, no browser, and you add the task, and you can see how it changed the file. So the same works on Windows. Pixi task add alias lab, Jupyter lab, no browser. So cat pixi.tom. So if you're looking on changes, now that you have this task, we can run. So we can do Pixi run. First, we can list the tasks if you want. Task is Pixi task list. So you see the list here. And if you want to run, you can do Pixi task run lab. Works on both, but I can only run one simultaneously. So we run on Windows this time for sake of example. So now before Pixi starts running this, it will resolve all the dependencies and it will start there. So I can copy this and then I can start on the browser. So we should have a JupyterLab here. So we have our Pixi Tom file that we added before. We have our R kernel, so we can do 1 + 1 as R. We did install ggplot too, so we can do library ggplot to ggplot 2. And we'll load the ggplot library. We can save this as notes if you want. So we can close that one for now. So on our Windows, we have the notes and everything that we saw with our first example of running tests we can do here. The next step will be commit that and add to GitHub. So you can check. There is no .git. This one was not initiated, so you can do git init to start this. You can ignore this warning. So now we can do a git add. So git status. So we to add our files. As I mentioned at the beginning, when you do Pixi init, Pixi will add some information on .git ignore and .git attributes. Mostly we'll ignore the .pixi file folder. So this one. So then do Pixi commit, git commit -n, add Pixi config. I can do I don't have my name here, git config global user mail. You can ignore this two commands because that's just me configuring the git in this environment. So git commit one more time, add Pixi config, and then I can do a git remote add orange with the address for GitHub, and I can do a git push orange and then you have your Pixi environments on GitHub, as was the case that we downloaded at the beginning of this lesson. So you would end up with something like the repository that we started. So it has your Pixi tom and the log file. So the tom will have your dependencies, your tasks, and the .log will ensure that whoever is using is getting exactly the same version for every single dependency that you use on your project, and that will reduce the chances of anyone having a different behavior than you had when you run your code. Which brings us to the end of this. Sorry, I keep. So there, as I say, there's a sheet at the end. There is some ways that you can activate your Pixi environment if you want. So you can do lots of normal work. So that's the Pixi shell, for example. Just for example, I can go on Windows and I can say Pixi shell. This means that now I will have a script installed on, not installed, it's installed on Pixi, but now my Windows PowerShell has direct access to iScript. The same works on Windows or Ubuntu. I can do Pixi shell and we'll activate it so I can have a script here. You notice that it adds a annotation on your command line. If you You can exit the Pixi shell. If you was curious, there's no iScript here on my default environment. There's no installed here on this Ubuntu machine, neither the Windows machine. So that's one way that you can have all your environments and work as you probably use it to on the command line. There's tons of features that you can look online in terms of integrations for different IDs or how to use on GitHub Actions. And you can also look on how to support multi-platforms if you need different versions of different libraries from different systems. And that's all. I recommend you to look more on the documentation. If you need questions, feel free to ask me or contact the Pixi developers on GitHub. The slides has a few more things if you're curious to look later, but that comes to the end of our slides. I will stop the recording now. If you have any questions, feel free to ask.